kids, welcome back. Again, my name is Sebastian the Sock Puppet. Yeah.
Pika, motherfucker.
Okay, bye Pikachu.
I'm the Harkness monster.
Okay, children, so today we will be talking about cosecant and secant. Yay! Yeah. Okay, so first we'll start with cosecant. So I'll have my good friend the Harkness monster hold up the cosecant for me. So first we'll talk about how cosecant is the reciprocal of sine. So we can write this by putting cosecant of x is equal to 1 over sine of x. Alright? So easy enough. And so needless to say, don't be despicable. Use the reciprocal. Yeah. Bye, Pikachu. Okay, so the next one, we'll look at secant. Secant is the reciprocal of cosine. So secant of x is equal to 1 over cosine of x. Again, don't be despicable. Use the reciprocal.
Pika.
Alright, so now we'll look at the basic graph for cosecant. So since cosecant is the reciprocal of sine, we drew in the sine graph using an orange dotted line. So on each peak or valley of the graph for the cosecant goes up following each peak and valley. So, and another cool thing about this graph are the asymptotes on it. So each asymptote is a total of 1 pi away from each other, and they're found at pi and 2 pi. So basically, our graph cannot go past that point and they follow along that asymptote. Alright, so pretty cool. It also has the exact same basic points on there. It has pi over 2, pi, 3 pi over 2, and 2 pi. So there you go. The period is also 2 pi. And yeah, cool. Bye. Now we'll look at the basic function, or basic graph for secant. Okay. So again, we drew in the cosine graph this time with an orange dotted line. So the orange dotted line follows the cosecant graph, and at each peak and valley, the graph for the secant graph goes up or down like that. And our asymptotes, again, are a total of pi away from each other, just like that. And instead, actually, for our asymptotes being at pi and 2 pi, our asymptotes are now at pi over 2 and 3 pi over 2. So there you go. That is the basic graph for secant. Okay, so now we have a couple example problems we can look at. We'll look at the example problem for cosecant first. Oh, there you go. Alright, so this is our example problem for cosecant. So our problem is y equals 2 cosecant parentheses x plus pi over 4. So we have two transformations going on in this problem, a vertical and a horizontal. We'll look at the vertical first. So we have a 2 going on in front of the cosecant. So all of our y values are going to be multiplied by 2. So instead of our y values being 1 and -1, they're now 2 and -2. So easy enough for that one. And now the horizontal shift is pi over 4. It's plus pi over 4, so that means we're going left. So our graph is shifted over pi over 4 to the left. So instead of starting at 0, pi over 4. Easy enough. Okay, so now let's look at an example problem for the secant graph.
Damn straight, Pika.
Yeah, okay, Pikachu. Yeah, in case you were wondering, our friends from the last video, Sebastian and Santiago, aren't with us this time because Sebastian, it was Sebastian who lost his eye last video, so he's in the hospital. And Santiago, I don't know where he went. He was something. I don't know. He's not here. Okay, anyways, so our example problem is y equals 3 secant 2 parentheses x minus pi over 3. Or is that 4? That's 4. Okay. Alright, so just like this, actually this is more difficult than the last problem because we have 3 transformations going on. So the number right here is the b term. The 2 is the b term. And so in order to find, see in this case we actually don't have to find the b term, but to find the period in this problem, we have to put 2 pi over b. So pretend that says 2 pi over b.
My bad.
Yeah, you're bad, Pikachu. Okay. So 2 pi over b. So it's going to be 2 pi over 2. And 2 pi, so the 2's cancel out if it's 2 pi over 2, and your period is going to be equal to pi. So instead of our period being 2 pi, it's now pi. Easy enough. So basically our entire cycle going through here is going to stop at pi instead of 2 pi. So again, we have our dotted line showing it's cosine this time because secant is a reciprocal of cosine. And so we have it showing with that, the cosine curve, and at each peak and valley, we have the going up or going down of the secant graph. And then we also have vertical and horizontal shifts. So our vertical, multiply all the y's by 3, 3 and negative 3. And then the horizontal shift of minus pi over 4. So we're going to go to the right, pi over 4. Alright, so instead of that, we have that going on and that going on. So easy enough. There you go. We'll take that away now. And let's see a few things about cosecant and secant graphs. So the domain is x cannot equal n pi, and the range is negative infinity to negative 1 and 1 to infinity. Alright, and so basically we refer to them as peaks and valleys in this video because when it hits the top we call it a peak, and when it hits the bottom we call it a valley. Alright, so easy enough. I hope this is helpful, and I hope you learned a lot in our video today. Say bye, Harkness Monster and Pikachu.
Pika.
Pika, bye!
Pika.
And that's our citation. Yay for citations. We didn't plagiarize.
Pikachu.
Woo!
Pika.
Bye, children. Yeah.